Good morning, students. Am I audible? Okay. So we are discussing the last topic of our first unit, that is our shear stress on the boundary. Okay. The equation for shear stress is specific weight multiplied by hydraulic radius multiplied by bed slope. So specific weight we also can write rho into g, okay, multiplied by hydraulic radius r multiplied by bed slope. This is nothing but your shear stress. Okay. So you can write it down. The expression, you write it down this expression, and you write where tau is your shear stress, small w is specific weight of liquid is also equal to density multiplied by acceleration due to gravity. Okay. Then you write this paragraph. Which is required boundary shear in uniform flow. Okay. Then this term, that is root over shear stress divided by density, will give you the shear velocity. Okay. You can write this line. Okay. The term root over shear stress divided by density represents the dimension of velocity, and it is called shear velocity, which is represented by u star. Okay. Which is represented by u star. Okay. So here you can see u star is equal to root over shear stress divided by density. Okay. So shear stress is nothing but our specific weight, that is rho into g multiplied by r into SB, okay, bed slope, then divided by density. This is your U star. Okay. So this density and this density will be cancelled out. What will be left out is acceleration due to gravity multiplied R multiplied by bed slope whole root. Okay. Okay. So you can write U star is equal to root over G into R multiplied by bed slope. Okay. So next is relation between roughness coefficient. Next is relationship between roughness coefficient. Okay. So here you can write another resistance coefficient called, this is not visible, this is nothing but your call Darcy's coefficient of friction. Okay. Darcy's coefficient of friction, small f. Okay. Another resistance coefficient called Darcy's coefficient of friction, small f, which is dimensionless and used in pipe flow. Okay. Okay. So you write in the next paragraph another resistance coefficient called Darcy's coefficient of friction, small f, which is a dimensionless and used in pipe flow. Okay. So according to some people, or you can say scientists, Darcy's coefficient friction may be used in open channel flow. Okay. Though we use that friction coefficient, Darcy's friction coefficient, for pipe flow, so some people says we can also use that Darcy's coefficient in open channel flow. But in that condition, when the pipe diameter is replaced by 4 times of the hydraulic radius. Okay. Whatever the equation we have for Darcy's coefficient, in that equation, if we replace the pipe diameter by 4 times of hydraulic radius, then that equation can be applied to open channel flow. Okay. So you please write down this paragraph. Over. Okay. Okay. So we are replacing the diameter by 4 hydraulic radius. Okay. This is the Darcy's coefficient equation, Darcy's equation. HF equal to head loss due to friction is equal to FL V square by 2GD. Okay. In place of this D, we are going to replace this D by 4R for open channel flow. Okay. When you are applying this equation for pipe flow, then this will be your equation FL V square by 2GD. Okay. There will be no change. But when you apply this same equation for open channel flow, then we have to replace this D by 4R. So from this equation, we HF multiplied by twice into G into D divided by FL, okay, is equal to velocity square. Okay, here this is your velocity square. So if you bring all the terms in the left hand side, it will be HF multiplied by twice into G into D divided by friction factor multiplied by length, okay, is equal to V square. You can write down this expression, okay. V square equal to twice G d HF. HF is nothing but head loss due to friction divided by F multiplied by your length. Okay. So here again twice GD by F is there, and then we have considered HF by L just to bring the friction slope, okay, because we know HF divided by L is nothing but our friction slope, okay. And see, when we talk about uniform flow, all these slopes are same except for only uniform flow, okay. Bed slope, surface slope, all are same, okay. So if you write here friction slope, because HF by L is friction slope, you can also write bed slope, because in our case for open channel our bed slope and friction slope is same. So that is why to bring SF we have used this formula, that is HF by length. Okay. So you can write this expression next. Everything will be same, only in place of HF by L you are going to write friction slope, okay. And you can write here, since HF by L is equal to SF, that is your friction slope, okay. So definitely here we have D, so that D will be replaced by 4R as we are discussing about open channel flow, okay. So V square will be there in the left hand side. In right hand side, in place of D we write 4R multiplied by SF. So this will be 4 multiplied by 2, it will be 8. 8GR divided by F multiplied by SB. Okay? So in place of SF, you can also write bed slope, because in open channel flow, all our slopes are same, or you can say equal. Please write down these expressions, okay, step by step. Here you can write this condition, okay. When there is SF and you have replaced that SF by SB, you can write this condition here. Since SF equal to SB equal to SW for uniform flow, for uniform flow, uniform flow. You can write this condition, okay. Am I audible? Okay, fine. Thank you. The next line you can write here, V is equal to, definitely this is V square, okay. So V is equal to root over 8G divided by F, and then we have separated this thing, okay, R by SB, okay. So put it number equation number 1, okay. The next line you write V is equal to, definitely this is square, so it will be under root. Okay, so we have separated hg by f, and then we have separated r into sb. Okay, why we have this separated, I'm telling you. Okay, in the next line. In some book, in place of sf, sorry, sb, you can find out sf. Okay, so don't confuse, because your sf and sb is same for uniform flow. Okay, it doesn't matter what you write. Okay, both are same. Okay, over. Okay, okay, so this equation we have already written, that is equation number 1. Okay, okay, so now we are using Sage's equation. Sage's equation. Okay, so we all know Sage's equation for velocity is v equal to c multiplied by root over r into sf. Okay, you can write sb, it's up to you. So this is our Sage's equation. Okay, so it's from this two equation 1 and 2, you can write c is equal to root over hgf. Okay, okay, so from this equation, if you compare, v is equal to root over hgf multiplied by root over r into sf. Okay, that is our equation number 1. In second equation, if you have seen, v is equal to c root over r into sf. So from these two equation, we can say c is equal to root over hg by f. So you write down this. Okay, this is important. Okay, this is the relationship between c and your friction factor. And if you remember, in previous class, we have already discussed that c is equal to r to the power 1 by 6 divided by n. Okay? There is a relationship between Sage's constant and Manning's equation. Okay? That is already discussed. So here is also you can write c is equal to root over hg divided by f is equal to r to the power 1 by 6 divided by n. Over. Okay. So next is our relationship. Okay. So when you solve problem, these two relationship are very important that you have to consider. Okay. That is, one is U star. U star is nothing but your shear velocity. You remember what is shear velocity? Shear velocity is nothing but root over shear stress divided by density. Okay, this is equal to shear velocity. Okay, and root over shear velocity is nothing but specific way, that is rho into g multiplied by your hydraulic radius multiplied by slope. Okay, divided by density. This will be cancel out. So ultimately you are going to get acceleration due to gravity r sb. This is your shear velocity. Okay. The shear velocity divided by velocity is equal to n, that is your Manning's roughness coefficient, multiplied by root over g divided by r to the power 1 by 6. Okay, that is one relationship. This is shear velocity with Manning's equation. Okay, if Sages is given, then this thing will be changed. Velocity divided by v, left hand side will be same, and this will be, because we know c is equal to, Says constant is equal to r to the power 1 by 6 divided by n. Okay. So here r to the power 6, n divided by r to the power 6. So it will be root over z divided by c. Okay. These are the two expression you should remember. Okay. If you remember one, then other one you can use this condition and you can come up with this equation. Okay. That c is equal to r to the power 1 by 6 divided by n. Okay. Kindly write down these two expression. Okay. Over. Then we move on to the numerical. Okay. So we are going to solve one numerical related to your shear stress. Okay. So what is given? A trapezoidal channel. So first thing, it is given as a trapezoidal channel. Okay. With, you kindly write down this question. Okay. A trapezoidal channel with bottom width of 2 meter with a depth of flow is 0.5 meter in a slope of, that is your base slope. Base slope is given. Okay. If the Manning's n is given and side slope is given 1 is to 1. I think you remember, if the side slope is 1 is to 1, it is very easy to calculate. We are going to directly consider z is equal to 1. Okay. If your side slope is 1 is to 1. Okay. So you write the question: a trapezoidal channel with bottom width of 2 meter, comma, with a depth of 0.5 meter in a slope of 0.0005. If the Manning's n is 0.015, and side slope is 1:1, find find number 1 shear stress, okay, number 2 shear velocity, number 3 Sage's constant, number 4 Darcy's coefficient of friction. Okay, so number 1 we need to find out shear stress. Shear stress equation is specific weight multiplied by R multiplied by SB. So you can find out the shear stress easily. Then shear velocity, U star, shear velocity we know root over G into R into SB. Okay, that we have already discussed. Okay, then we have Sage's constant. So C is nothing but your R to the power 1 by 6 divided by N. Okay, the N value is given 0.015. Okay, then Darcy's coefficient friction. So we also know C is equal to root over Hg divided by F. Okay, that we have already derived divided by F. Okay. So from here you can find out the friction factor, that is small f. Okay, C value is already calculated, so you can substitute here and you can find out the friction factor. So you kindly solve. Okay, try to solve. First you find out the shear stress. You always remember in the shear stress that small w is your specific weight, that is into rho into g. Okay, now the condition is rho. So rho you can take 1 gram per cc or 1000 kg per meter cube. Okay, so definitely the r value is again area by r is area by weighted perimeter. So if that area and weighted perimeter is in meter, then this 1000 also we have to take 1000 kg per meter cube. Okay, understood? So it's up to you. If you take 1 gram per cc, then you have to again convert into meter. Okay, because the other terms are in meter, or you have to convert this into centimeter. It's up to you. Okay, so first you just try to find out the shear stress. over. So to find out shear stress, we have this equation. Okay. So to find out here, first we have to find out the R value. Okay. To find out R, first we have to find out area and weighted perimeter. So those things we have already discussed for trapezoidal channel. Okay. Side slope is given 1:1, so Z is equal to 1. Width of the channel, bottom width is given 2 meter. Depth of flow is zero point 0.5. This is nothing but your ZY. This is also ZY. Okay. So those things we have already discussed. This is nothing but your width of the channel. Okay. So we have to find out top width. So Y value is zero point 0.5 and Z is 1. So it will be 1.5 and this is will be zero point 0.5. This is will be zero point 0.5 and this is also zero point 0.5. So 0.5, 0.5, 1 and this is 2, 3. That is why 2 plus 3. The top width is 3 meter top width. Okay. Top width is 3 meter. We find out the area. Then you have to take Pythagoras theorem and then you have to find out one side for weighted perimeter. Okay, so we have to consider these three sides for weighted perimeter. As the side slope is same in both the side, so we will find out one side and then we multiply it by twice. Okay, and in addition to B. If this is A, this is B, so twice of AB plus width of the channel plus width of the channel. Okay, that is your weighted perimeter. See, area you are getting 1.25 meter square. Okay, and how much you got weighted perimeter? 3.42 meter. Once you find out area and weighted perimeter, you find out the R value. Okay. Once you calculate R value, you substitute here. Okay. And see you are getting the value is this or not. Okay. Then you have to find out the shear stress, sorry, shear velocity. You can directly use this equation. Okay. Divided by 1. Or you can take 1000 also. It's up to you. Okay. As it is in meter square, so we have multiplied 10 to the power minus 3. If you bring it here, so it will be 1000. It's same thing. Okay. And see how much you got. Then you go for Sage's constant. This is very easy. R value, whatever you have calculated, you substitute here to the power 1 by 6 divided by n value. That is also already given 0.015. And see, Sage's constant, we don't have any unit. Okay, and then you find out the friction factor, okay, by using this equation C equal to hg by f. If you remove this square root, then it will be c square. So if you cross multiply, so f will be there and c square will be in the denominator. And c's value you have already calculated, substitute here and find out the f value. Okay? Very simple calculation. So we end today's class here. Next week we will start a new unit, that is your canal design. Okay. With this class we have also completed our first unit. Okay.